Today we're doing Newton's laws. So in Newton's laws come in different form. So the first one, we have the Newton's first law, whereby an object is moving at a constant velocity or it is stationary. Then we also have Newton's second law. So I think we are going to look at these two. So at Newton's second law, we know that the object is not moving at a constant speed or constant velocity, and it is also not stationary. So the object is accelerating. Yes. Okay. So we're going to take a look at some diagrams. I would like us to start by looking at a normal force. How to calculate a normal force on an object that is on a horizontal plane, or an object that is on an inclined plane. We're going to take a look at how to calculate normal force at different forms of object. So let us for now we're going to have something like this. The applied force here is 62 newtons. kg. We have kinetic friction here, which is 2,1. So how do we calculate normal force here? Okay, let us start by drawing a free body diagram. How to draw a free body diagram here? This is how we're going to draw our free body diagram. We're going to have a normal force. We're also going to have weight here. We're going to have an applied force. Then we have kinetic friction. Kinetic friction always opposes the motion of an object. Right, so let us calculate the normal force. Let us calculate the normal force. How to calculate the normal force? We know that normal force opposes the weight. So to calculate the normal force, we know that the forces acting upward are equal to the forces acting downward. Forces acting upward are equal to the forces acting downward. So the force that we have that is acting upward is only the normal force. So normal force is equal to weight. So the formula for weight is mg. So the mass of the object is 8. The mass is 8. The gravitational acceleration is 9,8. So 8 times 9,8 8 times 9,8 is 78,4 newtons. Right, this is our normal force. Then number 3, calculate the net force. So to calculate the net force, guys, we are going to consider the horizontal forces. So how many horizontal forces do we have here? Why do we consider the horizontal forces? It's because the object is moving in a horizontal plane. So that's why we are going to consider only the horizontal forces. So we're going to have F net equal to, so we have FA here plus FK. So we take right as positive. So FA is gonna be positive. We have FA here. FA is 62 plus then FK. Our FK is 2,1. So it's 2,1. So 62 plus 2,1 is gonna be 59,9, I think. Yeah, 62 minus 2,1, 59,9. Yeah, 59,9 newtons to the right. Right, okay. Now number 4, calculate the coefficient of frictional force, kinetic frictional force. So the formula for frictional force, we know that it's Fk equal to mu k n, whereby Fk is the kinetic friction of the object. We are given the kinetic friction is 2,1. Equal to mu k. So we know the normal force. The normal force is 78,4. 78,4. So we divide by 78,4 both sides. So our mu k is 2,1 divided by 78,4 is 0,02, 0,03 here. 0,03. Yeah, this is our coefficient of the kinetic friction. Okay, right. So let us look at an object that is that is on an inclined plane. Okay, before we go to inclined plane, I just want us to take a look if the applied force is applied at an angle. If we are given something like this, we have 62, then we have 20, 25 here, 25 degrees, then is 8 kg block. Okay, we are not given this, but we are given mu k, coefficient of kinetic friction 0.2. Yeah. So number one, draw a free body diagram. How do we draw a free body diagram for this one? We're going to have something like this. This is our applied force. This is our weight. This is Fk. And we're also going to have normal force. Yes, then here, this is the L between the horizontal plane and applied force, 25 degrees here. Right, so there is also another one whereby applied force has components. It's going to have the horizontal component and also the vertical component. We're going to draw it like this. Usually this one we use it for the calculations. And we're going to have Fy here, Fy, then Fx here, then we're going to have W, and this is kinetic friction. Right, so this is our free body diagram. Then number two, calculate the normal force. How do we calculate our normal force if we have something like this? Applied force is acting at an angle. We know that the sum of the forces acting upward is equal to the sum of the forces acting downward, which means N plus Fy is equal to W. Forces acting upward is equal to the sum of the forces acting downward. So the forces acting upward is N and Fy. So N plus Fy is equal to W. So the normal force is equal to W minus Fy. So the formula for W is mg. How do we calculate mg? We have mass. Let's substitute. Mass is 8. Then Gravitational acceleration is constant. 8 times 9,8. 8 times 9,8 is 78,4. 78,4 newtons. So we're substituting W with 78,4 minus Fy is, the formula for Fy is F sine theta, Fa, applied force. This F is for applied force. So our applied force here is 62. 62 sine 25. Sine 25. So 62 sine 25 is 26,20 newtons. So we have 26,20. Yeah. Right, okay. Then let's subtract 78,4 minus 26,20. This is 52,2. 52,2 newtons. You're right. This is our force. Okay, let's go to the next question. Then the next question, we have to calculate the kinetic friction. Let us calculate the kinetic friction. How do we calculate the kinetic friction? So we are given coefficient. We are given coefficient there. We also have normal force. We know the formula for kinetic friction is Fk equal to mu k n. So our mu k, we are given mu k there is 0,2. So 0,2 times the normal force. We have the normal force here. 0,2 times 52,2, 10,44 newtons. 10,44 newtons. Right. Then we are done with kinetic friction. Yeah. Let us move on to the next one. The next one, whereby we are going to calculate. We are going to have an inclined plane. This object is on an inclined plane. Something like this. Zero comma 2. This is our coefficient. Coefficient of kinetic friction. So this is our applied force, 62 newtons. So let us draw the free body diagram number 1. We need to draw a free body. free body diagram. Okay, we're going to have an applied force here pointing upward. Then we're going to have a normal force. Normal force is perpendicular to the surface, and we're going to have Fg, or weights W, and also we're going to have kinetic friction. Kinetic friction. Yeah, let us also draw the other one for calculations, whereby Fg has components. So we're going to have normal force here. We're going to have applied force here. Then we have Fg perpendicular. Fg perpendicular. Then we also have kinetic friction, Fg parallel. Fg parallel. Fg parallel always is down the slope. It's always down the slope, guys. Yeah, always. Then yeah, I think we're done. Yeah, we're done with this free body diagram. So number two, we're asked to calculate the normal force. Guys, this thing of normal force is very, very, very crucial. You need to know that the formula to calculate normal force is not the same. If it's on a horizontal plane, it's not the same with the one with whereby the applied force is acting at an angle, and also this one is also calculated in a different form. So n here, the normal force is opposing Fg perpendicular, so the normal force will be equal to Fg perpendicular. So we have something like this. Fg perpendicular is equal to mg cos theta. Mg cos theta. So m, the mass is 8. The mass is 8 kg, 9,8 cos the angle is 30 degrees. 30 degrees. So 8 times 9,8 cos 30, it's 67, comma 9 newtons. All right, yeah, then we are done with the normal force. We are done with the normal force. Now we are asked to calculate the what we call the frictional force. Yeah. As to calculate frictional force, the formula for friction is Fk equal to mu k, and so mu k, the coefficient we are given, the coefficient is 0,2, times the normal force. The normal force is 67,9. 67,9. So 0,2 times 67,9, 13,58. 13,58 newtons. Then we are done with the friction. Right, okay. Now, let us calculate the net force. How do we calculate the net force here? Net force is equals to, since we don't have the acceleration, we are going to take the horizontal forces, the forces that are parallel to the surface. So we have 62 as an applied force. We also have a kinetic friction acting downward. We also have FG parallel. We also have FG parallel is also acting downward. So we're going to add them. We'll add them, FA plus FK plus FG parallel. So FA is 62. FA is 62 plus FK, our FK is 13 and it's acting downward, so it's gonna be negative 13,58 plus FG parallel. We don't have FG parallel, okay, but we can calculate FG parallel. Let us calculate it here. FG parallel is equal to, the formula for FG parallel is mg sine. So the mass is 8. The mass is 8 grams. 9,8 sine 30. Okay, sine 30 is half of 8 is 4 times 9,8. Okay, 9,8 times 4, 39,2. 39,2, right, minus 39,2. So 62 minus 13,58 minus 39,2 is positive 9,22 newtons. Right, we're done with this one, the one which is acting on an inclined plane. Now I think we are going to look at two blocks that are let me see. Okay, yeah, now we're going to have something like this. Okay, yeah, now we're looking at two blocks that are pulling each other. Okay, So newtons here. We have 8 kg here. We have 2 kg here. Right. So mu k here. Mu k is equal to 0,1. Mu k here is equal to 0,3. Right. So let us draw free body diagram for both objects. So for the 2 kg block, we're going to have a normal force. We're also going to have a tension. This is a rope, so this rope has a tension. The tension for this block is acting to the right, then the tension for this block is acting to the left, and they are equal, just that they act in the opposite direction. So this is tension. We have Fk this side, then we have W. Right. Then for 8 kg block, we're going to have an applied force. We're also going to have normal force. Also going to have weight. This side we're going to have tension. We're also going to have Fk. So this one must be shorter than the tension. Yeah. Right. Okay. Then we are done with the free body diagrams for both blocks. Then number two, calculate the acceleration. Calculate the acceleration. We are asked to calculate the acceleration for both. Before we calculate acceleration, let us just calculate the normal force for both blocks. Yeah, the normal force. So for the 2 kg, we're going to say N is equal to W equal to mg. So 2 times 9,8. 2 times 9,8 is 19,6 newtons. For this block, we're going to have N is equal to, this N is opposing W, so N is equal to W equal to mg. So the mass is 8 times 9,8. 8 times 9,8. 8 times 9,8 is 78,4. 78,4 newtons. Upward, yeah. Upward. This one is also acting upward. And number 3, let us calculate frictional force for both blocks. So the frictional force for this one is Fk equals to mu k n. So mu k for this block is 0,1 here. The normal force is 19,6. So 0,1 times 19,6 times 19,6 is 1,96 newtons. Then let us calculate the kinetic friction for this one. Fk is equal to mu k n. So the mu k for this block is 0,3. The normal force is 78,4. Zero comma 3 times 78,4. 23,52. I hope guys you are also holding your calculator so that if I make a mistake you also confirm. You also confirm, make sure that my answer is correct, because I also make mistakes. So keep your calculator with you. Right, okay. So number 4, let us calculate the acceleration. How are we going to calculate the acceleration? Usually this one requires a simultaneous. So yeah, we'll see how to apply the simultaneous equation for acceleration to calculate acceleration. Okay, so F net is equal to ma. This is a formula for Newton's second law. So under F net we are going to consider the horizontal forces on the 2 kg block. We have T, which is pointing to the right. Then we have Fk is pointing to the left. So we're going to take all the forces that are acting in the right direction as positive. Yeah. So T is pointing to the right, so it's gonna be T minus Fk. T minus Fk equal to ma. Then T, we have Fk here. Fk for the 2 kg block, 1,96 equal to the mass. The mass is 2a. Then T is equal to, we make T the subject of the formula. So 2a plus 1,96. This is our equation 1. Then we go to the next block. F net is equal to ma. F net, we consider all the horizontal forces. So FA minus T minus FK. FA minus T minus FK MA. Right, so our FA here, our FA is 80 newtons, 80 newtons minus tension. We don't have the tension yet. Okay, FK, we have FK here, it's 23,52 equal to 8A. So we can add this 80 minus 23,52, 56,48. It's 56,48 minus T equal to 8A. Then we're going to substitute where we have T. We're going to substitute T with 2A plus 1,96. So it's 56,48 minus 2A plus 1,96 equal to 8A. Right, okay. So let us simplify. We have 56,48 minus 2A minus 1,96 equal to 8A. This one, we're going to transpose this one to the side. 8A plus 2A. Then this side we are left with 56,48 minus 9,96. 1,96, 54, it's 54,52, 54,52 equal to 10A. Then we divide both sides by 10A, 10. Divide both sides by 10. We're going to have 5,52. So our acceleration is 5,45. Yes, 45, sorry. This is our acceleration. This is our acceleration. Right. Then number 5. Number 5. We're going to calculate the tension. We're asked to calculate the tension. So if we are to calculate the tension, we just take this one, this equation. T is equals to 2A plus 1,96. T equal to 2A plus 1,96. Where there's A, we will substitute A with 5,45. 5,42 into 5,45 plus 1,96. 2 times 5,45 plus 1,96, 12,86. I get 12,86 newtons. This is our tension. Right. Yeah. Then we are done with this question. Let us check. Let us check another one. Let's check another one. In this situation, the applied force is acting at an angle. The applied force is 62 newtons. The angle between the horizontal and applied force is 25 degrees. Then this is 8 kg. This is 2 kg. So we are told that this is a question paper, guys. This is a question paper. It's Limpopo, March 2024. This is the information that we are given. We are given the acceleration there. We are given that it's placed on a rough surface. So if it's written rough surface, we know that we have kinetic friction. This kinetic friction. Then the tube block experiences a constant frictional force of 2,1. Given the friction here, 2,1 newtons. And we are also given acceleration. Acceleration is 3 meters per second squared. It's nothing else. Okay. Number 1. We are asked to state the Newton's law of motion in words. So I think you know this statement, right? It states that Newton's second law states that when a net force is applied on an object, the object will accelerate in the direction of the net force the acceleration directly proportional to the net force and inversely proportional to the mass. The mass of the object. Right, okay. So number 2, we're asked to draw the free body diagram. So let us draw the free body diagram for the 2 kg block. It's gonna have normal force, also going to have the weight here. We're also going to have the tension. We also have FK. Right, okay. Then we are done with the free body diagram of the 2 kg block. Let us go to the next block. We're going to have normal force here. We're also going to have the weight. Guys, okay. Please bear with me. I like to draw the one that we use for calculations. So we are going to have horizontal components for FA. We're also going to have FY here. Then we also have tension. We also have kinetic friction. Right. Then number three, they say calculate the tension. Let us start by writing the equation for the 2 kg block. We're going to say F net. We're going to use the Newton second law formula. F net is equals to MA. So we're going to consider the horizontal forces since it is moving on a horizontal plane. T minus Fk. We take right as positive. Don't forget to choose directions. So T is what we are looking for. Fk. We have Fk there is 2,1. We are given Fk 2,1 equal to the mass is 2. The acceleration is 3. So T is equal to 6 plus 2,1. We transpose 2,1 to the side. It's going to be positive. Then 6 plus 2,1 is 8,1 newtons. This is our tension. We're done. Then number 4. We need to calculate the coefficient of kinetic friction. We need to calculate the coefficient of kinetic friction. Coefficient of kinetic friction between 8 kg block and the surface. So how are we going to calculate the coefficient of kinetic friction? You know that we need to use the formula for kinetic friction, Fk equal to mu k, and so we need the normal force. Do we have the normal force for this block? We don't have. We also need kinetic friction. Are we given the kinetic friction? We are not given, which means we need to calculate these two. Right. Hey, it seems like we're going to work here. We're going to sweat. F net is equal to MA. Then here we're going to write all the horizontal forces. Fx minus T minus Fk. Fx minus T minus Fk